Okay, this is your graphing method video. You should have already used the substitution method and the elimination method. Um, each method has its own time that is easy and hard. The graphing method we typically use when you have at least one of your equations in the form of either y equals or x equals something, because then you can simply substitute in whatever y or x equals into the other equation and then find what x and y are. The elimination method we like to use when you have two equations in, say, like standard form, and you have things that are either opposites or easily opposites. So like if you have 3x plus something and the other equation is negative 3x plus something, the elimination method is probably a good choice, because when you add them up, the 3x and the negative 3x will cancel to 0, and then you have a much easier problem to solve. The graphing method is useful when you have a graph already given to you. So I guess I'm supposed to erase some of this. Okay, there's your little preview. All right, so let's say you have a graph and you already have two lines that are graphed for you. This is probably given to you. You use the graphing method. You are simply looking for the intersection point. So you look for where they cross, and they cross right here on this red dot. And you can always simply read it. So we read x, then y. If you forgot, x is across, they're labeled, y is up and down, so we go across 1, so x is 1. Up and down, we're not moving, so y is 0. And there's your answer, 1 comma 0. You can simply read it right off the graph and you're done. So like I said, if you already have a graph, this is a really easy method. The catch is, if you see the intersection points, you really want it on one of these grid lines. If it's over here somewhere in the middle, let's say you have this intersection point, this one's much harder to figure out what it actually is, and you're going to have to guess at it, and you're not going to be as accurate. So this method also has its drawbacks when you're in space. You really want your intersections to be on grid lines, so it has both pluses and minuses. This would be an example of a single solution. When you have your two lines, here I have both a blue line and a red line drawn, they end up being exactly the same line. Just like before, you're going to write infinitely many solutions. So this is infinitely many solutions. Or you might have two parallel lines. Anytime you see two parallel lines, doesn't matter if they look like these two, or let me draw you a pair of red ones. Maybe they're on diagonals. As long as you have two parallel lines somewhere on there, the solution to parallel lines is no solution. There is no intersection point, so you write the words no solution. So just like before, you got three possibilities. Two crossing lines, as long as they cross somewhere, you look for the intersection point. Then you write whatever that intersection point is. In this case, it's the point 1, 0. That's our single answer solution. Two lines that happen to be the same line, you would write infinitely many solutions. And if you have two parallel lines, you're going to write no solution. So maybe instead of having a graph done for you, you're given equations like y equals x minus 3, and maybe you have 2x minus 3y equals 4. Let's make that a little easier. We'll make this a 6. Okay, 2x minus 3y equals 6. So let me show you how to graph these. If you're going to use the graphing method, you first have to graph them. Personally, I would use the substitution method here because I see y equals, so I can take this y and substitute x minus 3 right in here and then solve for x. That's how I would do it. But let's say you prefer the graphing method. There's nothing wrong with it, so let's graph it. If you have it in this form, this is y equals mx plus b. Remember, the b is your y-intercept. The m is your slope. So I look for the y-intercept, which is b, and our y-intercept here is negative 3. So on the y-axis, I go find negative 3, and I put a point. The slope is the coefficient of x. In this case, there's a hidden number here. It's the number 1. It wasn't written, but it's always there. So we need to write this as a fraction. So this is the fraction 1 over 1. And remember, slope is always rise over run. So this means I'm going to rise 1, and then I go run 1. The runs are always to the right. So I don't start at 0, 0. I start at the y-intercept. I'm going to go up 1 over 1. I get to put another point. And I can repeat that as many times as I would like to. You only need to have 2 points to make a straight line. But if I need to make a really straight line, you might choose to make extra points. I'm then going to connect these points with a nice straight line. and put an arrowhead on the end because this line goes forever. And there's your line y equals x minus 3. Let's look at this other one. This time I'm going to use the intercept method. To find the x-intercept, you know that y equals 0. So I'm going to make y equals 0. That means this is negative 3 times 0, so that cancels. I'm left with 2x is equal to 6. I'm going to divide both sides by 2. This is why I changed that to a 6 from a 4. 2 divided by 2 is 1, so I get x. 6 over 2 is 3. So in this case, the x-intercept is 3. So I go find on the x-intercept, I go find 3, and I put a dot. That was kind of nice. And then to find the y-intercept, I know that x is 0. So this time, x is 0. That means 2x is 0, so I'm left with negative 3y is equal to 6. Divide both sides by negative 3, and y ends up being negative 2. So on the y, I go find negative 2, which is right there. And then I'm going to connect those dots with a nice straight line. Yeah, that's not a bad straight line. Hopefully your lines look as straight as that. That's a pretty good one. Okay, and then we're looking for the intersection point. Well, we already know what the intersection point is because we had two solutions that were right here. So we're going to read it off, and it says that this is at 3 on the x and 0 on the y. So our intersection point for this one is the point 3, 0. So you can always use the graphing method if you feel comfortable with graphing. Some easier graphs might be this one. Let's say I give you the line y equals 1 and x equals 3. You simply graph those two lines. The line y equals 1 is you go up to the 1 on the y and you draw a horizontal line straight across. The line x equals 3 is you go by 3 on the x and you draw a vertical line straight up and down. And we're going to quickly look for the intersection point, and because these are nice straight lines, you can see the intersection point is right here at 3, 1. So this one I might consider using the graphing method because graphing for these tiny lines is very simple. The other method for graphing is to use your graphing calculator. So I'm going to show you the graphing calculator with this one. At least I'm going to attempt to. So let me move that off and get our graphing calculator up. When you first bring it up, you're going to get the menu. Remember, you might have to, this is not Sketchpad, this is the new documents. You might have to say, please don't save the new documents, but we're going to add a new document. Then under menu, you're going to add a graph because we want a graph today. And it comes up with this f1 of x. Remember, f1 of x is just another way of saying y. So this is in y equals form. In order to graph it, you have to put them in y equals form. So that might be some of your challenge. But look what happens here. I'm going to graph this one. It says y equals x minus 3. So I'm going to say y equals x is down here at the bottom, x minus 3. There's y equals x minus 3 and hit enter, and there's graph for you. If you want to add another graph, you just tap in here anywhere on the screen and it'll bring it back up for you, and I want f2 of x. Now this time I want to graph this second one, but it's not in y equals form, so I'm first going to have to solve it for y equals form to put it into the calculator. So I get 2x minus 3y equals 6. I want y by itself, so I got to move this 2x, so we're going to subtract 2x, and if I do it on one side, I must do it to both sides. The 2x's cancel, I'm left with negative 3y. And here, these are unlike terms, so we're going to just leave this as 6 minus 2x. I still got to get rid of this negative 3, so we'll divide everything by negative 3, which means I divide everything over here by negative 3. So we're going to say y equals 6 over negative 3 is negative 2. And a negative over negative is positive, and this is 2/3 x. So it's now in y equals form, so I can type in y equals 2/3 x minus 2, or negative 2 plus 2/3 x. Those mean the same thing. So let's type it in. I got negative 2 plus 2/3 is 2 divided by 3, x. So negative 2 plus 2/3 x, and let's hit enter. Whoa, what happened to it? Maybe I do have to put it in y equals form. Okay, so we're going to go 2/3 x minus 2. Hit enter. There it goes. Apparently you do have to put it in that form. So 2/3 x minus 2. And we want to know what this intersection point here is. You can already see what it is, but I want to show you, if it's not a nice, neat point, how you can let the calculator do it. So you go under, I believe it's menu, and you want to analyze the graph. Anytime you're looking for a point, it's analyze a graph, and in this case we're looking for the intersection, which is number 4. And then it's asking you what is too far to the left and too far to the right. So we know it's right here. So move the line to the left and just click on it, and then move the line to the right. As long as the intersection point is in the shaded region, you're fine. And then you step back, and it tells you right here that it's 3, 0, and you're welcome to move it around. It says for you the point is 3, 0, and if we look back at what we did before, we found that it was 3, 0, so apparently we were right before. So let me go ahead and get us a new graph in here. Menu. Let's do Control I. I know Control I works. Control I for insert. Let's insert a new graph. And here I'm going to just do some random ones. So let's say y equals 3x minus 14. And let's do another one. So I need another one. Remember, just double click will get you a new one. Let's say y equals 14x minus 34. Obviously, I have no idea what the answer is. I just made those up. I can't even see my two lines, so what I end up needing to do is zoom out. So we're going to go to Menu, the window, and let's zoom out. Ask where the center is, and we put the center down here because I want it near the intersection point anyways, and there's where it crosses. I have no idea what that is, so let's go to Menu. We're going to go to Analyze Graph, and we're going to go to the intersection, and I need something to the left. That's way to the left, something to the right, so I'm going to click to the right, and it says that our intersection point is 1.82, negative 8.55. So there you have it. It's not a nice, neat point, but the calculator's done your work for you. So you got several different options. You can use the graphing method if you have things that are easy to put in the calculator or graphs already for you. You can use the substitution method if you have a y equals or an x equals that's easy to substitute. Or you can use the elimination method if you are able to have things that easily cancel out, like a 3x on the top and a negative 3x on the bottom. If you have any questions, go ahead and ask them in the discussion board post. And if you are perfectly clear in your understanding, make sure you go ahead and make a comment that shows me that you watched this video.